Hello, dear students. Assalamu alaikum, and I hope you are very well by the grace of Almighty. So, in today's video, we are going to solve. I'm going to solve a few questions related to mensuration topic according to the syllabus of O-Level Cambridge Maths D and Edexcel IGCSE Maths B 9-1, and I'll try to solve questions related to paper 2. Those who are studying Edexcel O-Level Maths B, and also the students who are studying Cambridge O-Level Maths D, you already know that in paper 2 you're going to face 10 to 12 questions. I think 10, 11 questions, and some of the questions are pretty large question. I mean, the question may carry 10 to 12 or 15 marks, and those questions are quite difficult. So we're going to solve some questions from paper 2. Actually, the question I'm going to solve is taken from past paper of Cambridge O-Level Maths D, but the students of Edexcel also follow this question because your question pattern is somewhat similar. Okay, let me share the question. Okay, so when you are going to watch the video, make sure you have solved mensuration questions from the book. There are a lot of good book from where you can practice those questions, but the book generally I follow, you can follow that book, Complete Mathematics for Cambridge IGCSE 5th edition, and it's a very good book. The 4th chapter is related to mensuration. You will find total 10 exercises, very good questions are there. I mean, the exercises are arranged in a very organized manner. I personally like it very much, and I also follow in my classes. And at the end of the chapter, you will also find revision questions, revision exercise, and also exam style exercise. Sorry, I made a mistake. It was chapter 3. Okay, it was chapter 3, mensuration. You can also follow other books. There are plenty of books, but I personally follow this book. So make sure before solving these questions or watching this video, you should make sure that you have practiced all the formulas and theories related to mensuration and all the exercises from at least one of the book. Okay, so let's solve this question. Actually, I've typed the questions by myself. So in the question paper, you will find the questions are arranged in a little bit different manner. Anyway, but actually I have organized all the mensuration questions in one paper, and I try to give the handout to students so that they can solve as many questions as they want. So I'm particularly solving question 4. Now, in question 4, some informations are already given, and in the questions, you will find out that some informations are already given in the question, like they have asked you to consider the value of pi as 3.142, and also they have given the formula of the surface area of sphere and the volume of sphere. That means we're going to use this formula in solving these questions. And it's a pretty big question. The total mark of this question is 4 plus 2, 6, 10, 12. 12 marks question. And if you look at the question B, C, D, one of the questions is related to another. I mean, C is dependent on B, D is also dependent on C. That means if you make any mistake while solving A or B, then your answer in C and D are not going to be correct. The answer will be wrong, even though you may get mark according to the correct procedure if you follow the procedure, but somehow for putting wrong wrong data, you can make a mistake. In that case, you can have the method mark. Anyway, that's different issue. I'm not gonna go into that. So let's solve the question. A closed container is made by joining together a cylinder of radius 9 centimeter and a hemisphere of radius 9 centimeter. If you solve the questions from the book, you already know the term. Sphere, it's like a so you already know about spherical structure like football, tennis ball, golf ball. These are called a sphere, and if we cut it into equal half, then that half part will be called as hemisphere. Okay, like say for example, you are having a sphere, and if you cut it into equal half, then each part will be called as hemisphere. And what are cylinders? Cylinders, the structure of cylinder is like that. Like say for example, a Coke or Pepsi can. Okay, but it has to have uniform cross section. Uniform cross section means if you cut it like this, the top surface area that you can see, the surface area is not going to be changed. So it's called as uniform cross section. Uniform cross section. So that means this area, this circular area, from wherever you are cutting the cylinder, it's not going to be changed. So the closed container we can see here is actually a combination of a cylinder and a hemisphere, and it's a container, and it's a closed container. Closed container means this side is closed. I mean, whole thing is closed. Okay, and we also say that the water is there. Yes, it's exactly, the container rests on horizontal surface and is exactly half full of water. Exactly half full of water. So these informations are very important. Now, in questions, generally, the dimension of the diagram, I mean length, breadth, height, radius, these things generally shown in the diagram, and also it's written in the questions. But sometimes it may happen that all the values are not shown in the diagram but written in the question. So you have to look at the diagram properly, and you also have to go through the question properly. The most important thing initially while answering a question is to understand whether you have understood the question properly or not, and what the question is asking from you. So you need to understand it at first. So all the informations are given. So first question, calculate the surface area of the inside of the container that is in contact with the water. Give your answer correct to the nearest square centimeter. Calculate the surface area of the inside of the container that is in contact with the water. I mean, we can see that half of the container is filled with water, and we need to find out the surface area of the container that is in contact with the water. So if you want to solve it, as this is a combined structure which is a combination of a cylinder and a sphere, so we have to use the formula for cylinder and sphere to find out the water that is in contact with the cylinder, and also sphere. So that means you need to know the formula of this structure. Like in case of cylinder, what's the formula of the surface area of the cylinder? It's 2 pi RH. It's 2 pi RH, and it's actually the surface area of the curved surface. I mean, say for example, this is a can. You are holding the can. The surface you are holding is actually the curved surface of the cylinder. Curved surface of the cylinder. Okay, so if you look at here, the water is in contact with the curved surface of the cylinder, and also a semicircle here. Also, there is a semicircle in which the water is having contact with the semicircular area as well. So let's start with the semicircle. The surface area. So area of circle, pi r square, and as it is a semicircle, I mean half circle, so it will be pi r square by 2. Okay, next, curved surface area of cylinder. Now curved surface area of cylinder is 2 pi RH or 2 pi r L. L or H, it means the length of the cylinder. L or H, the length of the cylinder or the height of the cylinder. And it's in contact with the half curved surface area of the cylinder. Okay, so 2 pi RH divided by 2. Okay, 2 pi RH divided by 2. Next, this is already a hemisphere, half of a sphere. And if you look at this part, the water is now in contact with half of the hemisphere. So that means 1/4 of the surface area of a sphere. This is already a hemisphere. This is already a hemisphere. That means half of a sphere. And the water is in contact with half of the hemisphere, or we can say that 1/4 of the sphere, or we can say that 1/4 of the sphere. Now, what's the formula of the surface area of a sphere? It's 4 pi r square. 4 pi r square. The surface area of a sphere is 4 pi r square. So 4 pi r square divided by 4. Why? Because if you look at here, the water that is in contact with the sphere, part of sphere, that is actually half of hemisphere. So that means 1/4 of the sphere. Okay, so I think we have got our formula right. So just now we need to put the values, and you need to put the values carefully. So radius is already given, 9. You can see that from the figure. So put the values. We can cancel that too. Now this is paper 2, so you can definitely use the calculator. So no problem. If it was paper 1, and if it's Cambridge O-Level Maths D question paper, then you cannot use the calculator. Okay, but as it is paper 2, the use of calculator is allowed. So 2 and 2 cancel. The value of R is 9, it's given. And H means length or height, whatever you call it. That's 18. Radius is 9. Now, here, you can think like, what should be the radius of the hemisphere? What should be the radius of the hemisphere? Now, in the questions, it's clearly mentioned that closed container is made by joining together a cylinder of radius 9 cm and a hemisphere of radius 9 cm. So look at here, the radius is not shown. The radius of the hemisphere is not shown in the diagram, but it's being said in the question. So 4 and 4 is cancelled. Pi r square, radius is 9. Okay, so now from here you can calculate it. Now I've already calculated it, so I know the answer, and they have asked to find out the answer correct to the nearest square centimeter. So in point, the answer will be in decimal. The answer will be 890.64 centimeter. But we have to find out the answer correct to the nearest square centimeter. Correct to the nearest square centimeter. So that means, say for example, I've given, say for example, the length of a pen is 6.3 centimeter. Just say for example, and I've asked you to write down this value correct to the nearest centimeter. Then what should be the answer? It will be 6 centimeter. Now, if the length of the pen is 6.9 centimeter, so what should be the answer correct to the nearest centimeter? It will be 7 centimeter. Okay, so when you are having a decimal value, which is having the decimal digit as 5 or greater than 5, then you need to increase the value to the nearest integer. And if the value is less than 5, like 6.3 here, if the decimal digit is less than 5, then you need to convert it to the lowest value, lowest integer, to the lowest close integer. So the answer will be 891 centimeter, and that's a correct answer because I've already matched it. Okay, so I think you have understood, and the question is carrying 4 marks, so you need to do it carefully. Okay, so let's move on to question B. In question B, so that the volume of the water is 972 pi centimeter cube. I mean, the amount of water the container is holding, we need to find out the volume of that water. Now, again, as this closed container is a combined structure of a cylinder and a sphere, a hemisphere. I'm sorry. So that means we need to use the formula for both cylinder and hemisphere. Okay, so let's find out. The mark is 2 because the working is not that much like of question A. So the volume will be, now what's the volume of cylinder? The volume of the cylinder is pi r square h. Pi r square h or pi r square L. Now, the water that is in contact, and in the question, it's already mentioned that the container rests on a horizontal surface and is exactly half full of water. So we need to divide it by 2. Pi r square h is the volume of the full cylinder, and as the water is in the quantity of water is exactly the half of the whole container, so pi r square h by 2. And in case of hemisphere, already, what's the volume of a sphere? Volume of a sphere is 4 by 3 pi r cube. Now, what should be the volume of a hemisphere? Half of that. 4 by 3 pi r cube. Half of that. So 4 pi r cube. Another 2 here. Why? Because hemisphere is half of 4 by 3 pi r cube. Half of 4 by 3 pi r cube. Now again, the water is holding is half of the hemisphere. So that means we need to introduce another 2. Okay, so it will be 3 into 4. So 4 and 4 are cancelled. Now if you find out, if you calculate it, the answer will be 972 pi. 972 pi. And that's what we have to find out, because the question is asking to show that the volume of the water is 972 pi. Okay, so let me explain this part again. Okay, let me explain this part again. So volume of a sphere is 4 by 3 pi r cube, a full sphere. Now here, this is hemisphere, half of sphere, and the water that is, and the water here, this hemispherical part, it's half of hemisphere. So that means 1/4 of the sphere. So this formula has to be divided by 4. When we are finding out the volume of the water, it needs to be divided by 4, which actually can be written like 4 pi r cube by 3 into 4. Okay, so 4 and 4 are cancelled. Now, if you use the calculator, you will get 972 pi centimeter cube. Okay, so I hope you have understood it. So let's move on to next question, question C. Now here, the container is held with axis vertical, the hemisphere being at the bottom, as shown in diagram 2. Calculate the depth of the water. Initially the container was like that, like this, but now we are keeping the container in this way. So now we have to find out what is the depth of the water. The depth of the water means we need to find out this value. We need to find out this depth. Say, for example, let's consider that as h. Okay, so how we can solve it? we already know the volume of the water because we have found out this question previously in question B. So 972 pi equals to, now this is a cylinder. Let's consider the height of the cylinder as h. So what's the formula of cylinder? Pi r square h plus. And this is hemisphere. Hemisphere is half of sphere. So 4/3 pi r cube, half of 4/3 pi r cube. That's the volume of the sphere. Now let's put the value here, 972 pi. The radius was 9. It was given in the question. Height, we don't know about it. We have to find it out. So here 2/3 pi. And the radius of the sphere is also given, which is 9 as well. Now we just have to simplify it. Now you can eliminate pi from all the term. You can eliminate it. So now if you make h as the subject, I'm not going to go into that calculation. I've already done it. It's correct. So you can practice it by your own. I think it's simple algebra. You will be able to do it. Now from here, if you solve it, the answer will be, you will get the answer as 6 centimeter. But let me check again if I have made any mistake or not. 1 second. That's correct. H equals to 6 centimeters. So the height of that cylinder is h, 6 centimeter. But the question was asking about the depth of the water, and it's also carrying 4 marks. So depth of water means so the height of the cylinder, also the radius of the hemisphere. It was 6 centimeter and the radius is already 9 centimeter. So the depth of water will be 9 plus 6, 15 centimeter, and it's correct. I hope you have understood it. So let's move on to question D. Now here, the container is now placed with its circular end on a horizontal surface. Now, you have placed the container like this. Look at the diagram 3. Initially, it was standing on the spherical surface, hemispherical surface. Now, you have changed it, and now the container is standing on its cylindrical base. Okay. Now, in this situation, so definitely the water will be, now it will look like this. I mean, the position of the water, the container is now placed with its circular end on a horizontal surface. Find the depth of the water. Now, we need to find out the depth of the water. Now, if you look at the diagram, we can say that now the water is taking the shape of the cylinder. So our work has become comparatively easy, and that's why the question is not carrying 4 marks. The question is having 2 marks because we don't have to do much work here. So we will just simply apply the formula of the volume of cylinder, which is pi r squared h. And we know the volume of the water, which is 972 pi. The value is given in question B. So eliminate pi from both sides. The radius was 9. It's also given in the question. So from here, h will be 12 centimeter. And that's also a correct answer. So that's the question. And I'm telling you again, before going into that question, try to solve all the exercise of mensuration from the book. You can use any book. There are a lot of books, but I personally prefer this Complete Mathematics for Cambridge IGCSE. So go through the questions of chapter 3 and also solve mensuration questions related to paper 1. Then go into paper 2, because in paper 1 you will get very short questions, but those questions are also tricky. Some of the questions are very tricky, like if you don't understand the formula very well, you won't be able to find out the answer. And for answering some questions in paper 1, you really need to develop a strong instinct of understanding the questions very quickly and respond accordingly. But to achieve that instinct, some of the students already have that instincts, I know, but those students who are who cannot get the idea very fast, for those students it will be better for you if you try to solve as many questions as possible. So after doing the book, solve as many questions as you can from paper 1, because those are comparatively short questions, and paper 1 will help you help you sharpen the basics of mensuration, how to understand the questions and answer the question. Then go to paper 2, because now when you will go to paper 2, as you have solved the questions from the book and paper 1, so that means you are well aware of the formula, all the formulas of different structure, and you already know how to apply them. So paper 2 will be comparatively easier for you. So thank you very much. I hope you have understood it. And if you do have any question or any suggestion, please write on the comment. I'll try to follow your suggestion if it's important. So thank you very much for that.